Good morning, ladies and gentlemen. My name is Inge Bruheim. I'm going to talk to you today about some new and really intriguing results we have from our research on krill oil. The title of my presentation is The New Quality Markers of Krill Oil. First, I would like to tell you about Olympic Seafood. Olympic Seafood is a Norwegian company located on the west coast of Norway, in a region famous for its marine traditions and its fishermen. Olympic Seafood is an offshore and fishing company, having around 25 vessels operating around the world, outside Norway, outside Brazil, outside the United States. But Olympic started as a fishing company, fishing for shrimps in the Arctic, and we learned a lot from this experience, the importance of the equipment, importance of the people, and also the respect for nature and its resources. We are located in an area famous for the omega-3 industry. It's an history over 200 years, going back to produce cod liver oil in our region. Olympic Seafood aims to become the leading supplier of Antarctic krill ingredients for human applications. The Rimfrost company group consists of Olympic Seafood and its subsidiary Olympic BIOACTIVE, and as well the joint venture Rimfrost USA. 2 years ago we launched the Rimfrost Krill Collection. It's an ingredient brand comprising of Antarctic krill meal, powder and oil. We source our own raw material in Antarctica. We own the vessel JUVEL, which you can see a picture of here, on the way to Antarctica. JUVEL is a highly specialized and unique vessel with a highly unique technology on board to produce high-quality krill products, which I'll talk more about later. We have production in the United States and also in New Zealand, and we distribute product through Olympic BIOACTIVE in New Zealand. Rimfrost operations are truly a global operation. If you see down here, this is the Antarctic Peninsula. This is where we harvest and go for fishing the krill. The krill is then brought on shore in Montevideo in Uruguay. From there it's shipped to either Maryhill, North Carolina for extraction, or it goes to Nelson, New Zealand on the South Island, also for extraction. And from there we distribute products into the world markets. Our head office, as I said, is in Norway, a small town called Fosnavåg on the west coast of Norway. This is our vessel, the JUVEL, in the fishing grounds in Antarctica. For us, responsibility, transparency, and traceability is very important in all operations we have. It's the most modern vessel at the fishing grounds in Antarctica, and it's the newest vessel. We have introduced the concept eco-collecting, which describes how we do our business in Antarctica. It comprises of commerce, technology, and ecology. First of all, transparency and trust is one of the main pillars. We support the strict regulations from CAMLR. We do real-time monitoring of all the catches to the CAMLR and to the Norwegian authorities. We always carry independent observer on board, and all the products and all we do is 100% traceable. As I said, the technology on board the JUVEL is very important. It's a very environmental friendly technology. We have minimal trawling time. We don't have any continuous pumping system, no continuous trawling. We don't have any bycatch, and there's no bottom trawling. All the krill material, because of this trawling technology, is processed immediately on board. So the factory on board JUVEL is only processing on fresh krill. That's important to maintain a good quality of the krill products. And we focus on only small quantities. And the JUVEL is equipped so that all the products can be made for human consumption. We're not there to produce feed. And for this reason we have been certified by Friend of the Sea, an independent non-governmental organization. And in future, we will also have the MSC, Marine Stewardship Council certification. So this is what it's all about. This is the Antarctic krill. It's pure and it's strong. And it's a highly successful species in Antarctica. It's a huge biomass, one of the largest biomasses in the world. And what's interesting about krill, that it's rich in omega-3 phospholipids and it's rich in astaxanthin and other nutrients. So the krill is also living far away from any man-made pollution. So it's really a pure source of omega-3. This is our krill oil. We call it the Rimfrost Sublime Krill Oil. It contains 42% omega-3 phospholipids, 24 gram per 100 gram omega-3 fatty acids, and at least 400 ppm astaxanthin esters. And as I said, it's low level of pollutants. But just looking at the omega-3 phospholipid content, omega-3 content, it is fairly similar to the other krill oils on the markets. We don't concentrate the omega-3, we just take what's naturally present in krill and extract that out into an oil. So the product may look very similar to other krill oils on the market, but if you look more in detail, you'll see that's a big difference, and we'll get back to that later in the presentation. But first I would like to show you a new innovation that we have launched and are able to supply in large quantities. It's a stable form of krill oil in dry form. It's all natural krill, and it's a composition of krill lipids and krill protein. It's actually all the good things in krill, but we have taken out the shells and the water, and we have dried this, and we have been able to mill it down to a nice powder, which can then be put into capsules. Now back to the krill oil. Why should people take krill oil? It's a source of omega-3 fatty acids, and it's a source of omega-3 phospholipids. So the good thing is that it can do all the good things omega-3 fatty acids can do. But it's more bioavailable, more bioefficient, since it's bound to the omega-3 form. And it's beneficial for heart health, joint health, and autoimmune diseases, and all these omega-3 effects, but at a stronger effect at a lower level. And we have done a small clinical trial with 20 people. It was registered on clinicaltrials.gov, looking at heart health. This is data with Rimfrost Sublime, which we have not published yet. And we see for these 20 healthy students, 832 milligram per day EPA-DHA in the form of Rimfrost Sublime. We get a significant increase in HDL cholesterol, which is a good cholesterol. And we see a significant decrease in the plasma triglycerides. So this is able to improve the lipid profile in students. However, it's few people. So this is just an indication. But we see from the other data that the same people during the same period managed to double their omega-3 index, going from 4 to about 8. So it's clearly been taken up and utilized efficiently by the body. Now I'll move over to some more data we have on the chemical research we have done. What we have seen, and others have also observed this, but the krill oil is truly a much more stable form of omega-3 than fish oil. We have applied this equipment here. It's called an oscillograph. It measures what's called the induction time. How long time do we need to oxidize an omega-3 oil? We see that for Rimfrost Sublime it takes a lot longer time than for fish oil. So this is a confirmation again that krill oil is a much more stable form than fish oil. We published this data last year in the European Journal of Lipid Science and Technology. But we wanted to explore this more to find out why is it really more stable. So we went out and purchased cod liver oil, and we purchased some, we made an agreement with the university in Denmark to help us do this research. And we also got some funding from the Norwegian government, comparing cod liver oil and then Rimfrost Sublime. The products were exposed to air and stirred constantly in darkness and incubated then for 40 degrees for 21 days. And we looked at the range of conventional markers for oxidation. And there's a big difference. Again, fish oil show high peroxide value, high anisine value, high level of lipid-derived volatiles. There's a decrease in tocopherol content, high level of conjugated triins, and T-bars are high. So all the conventional markers of oxidation shows that fish oil is oxidizing quickly. But for krill oil, there was no change or very low change. Again, a confirmation of the high stability of krill oil compared to fish oil. But interestingly, we didn't see any change in peroxide value. Not for our oil or any competing brand. We went out and purchased krill oils from competing brands, and there's no increase in peroxide value. So our suggestion is that peroxide value is not a suitable measurement for determining oxidation in krill oil. So what have we learned so far? Krill oil on the market, they have more or less the similar level of omega-3s and phospholipids. It mirrors what is in krill naturally. Krill oil oxidation is very little known. We think and we propose that there is no need for new markers to document krill oil quality. JUVEL has a new and a patented process which combines short and gentle processing. We think that provides some additional benefits to the product. Now, what is this new process on JUVEL all about? Here is an overview of what we are doing on board JUVEL. We take out carefully small quantities of krill by precise trawling, and we do that when we see there's a capacity in our factory. Then the krill is hydrolyzed by adding proteases, so enzymes degrade the proteins into peptides at very low temperature. This allows us to efficiently remove the shells from the krill. And the shells are not good to have in the product. They are a source of fluorine, so we want to take that out. And that can be utilized as a separate product to make chitin or glucosamine. Then we do a drying of the sediment which we form. We separate out the sediment from the water. And sediment is dried under low temperature and vacuum. Then we bring this ANTARCTIC krill meal, which is really a peptide phospholipid complex, to land for extraction, use ethanol extraction, to make the Rimfrost SUBLIME ANTARCTIC krill oil. So more about lipid oxidation. Krill oil in the beginning oxidizes the same way as any omega-3 oil. You have free radicals, they initiate the oxidation and you form peroxides. But peroxide value never increases in krill oil, so you cannot detect by using the peroxide value measurement. But we do form aldehyde, ketones, and alcohols, and tertiary lipid oxidation products. But due to the dark color in krill oil, it's difficult to get accurate measurements for the aniline value. So you get interference from the other products in the krill oil. What actually happens is that you get a non-enzymatic browning reaction. These tertiary lipid oxidation products, they react with other components in krill oil. They react with amino acids, they react with amines, like in phosphatidylethanolamine, and they react with proteins. So you never get any high value of peroxides. They react with other ingredients, and they form Strecker degradation products, parols, like these ones here, and they have brown color. So you can see when a krill oil oxidizes, it goes from this clear red color to a brown color. And further on, it will polymerize, forming polypyrols. Long chains of pyrols, which are brown, high molecular weight, causing an increase in viscosity. So if you see a krill oil, which is brown in color, high in viscosity, it's a sign of an oxidized krill oil. We think we can provide some new technology to measure these Strecker degradation products by dynamic headspace GCMS, and you can measure the pyrols by spectrophotometry. And we have done that in the same incubation experiments which we showed you earlier. We see the increase in these Strecker-derived degradation products. For fish oil, there's no change. There's no amino acids in fish oil, so you don't see any increase, straight line. But for krill, sometimes it increases after time, and sometimes it is high in the beginning and then goes down. For this one, it increases initially and then goes down. So it's difficult to find a good pattern, so we don't want to follow this Strecker degradation products further. Instead, we wanted to see on the pyrols. Again, we see a dramatic increase in the hydrophobic pyrols. The hydrophobic pyrols are these browning compounds. And there's increase in the hydrophobic ones, which is formed by reaction with PE, phosphatidylethanolamine, one component in krill oil. Hydrophilic pyrols, these water-soluble particles, they're formed by reaction with proteins. There's no change there, indicating that the main reaction pathway in krill oil is the reaction with PE. This also is the same publication, European Journal of Lipid Science Technology, back in 2013. Now we wanted to explore, is it important, the temperature? Yes, we see an important effect of temperature on the quality of krill oil, meaning it's very important through all the processes on board the vessel to keep the temperature as low as possible. We do that by using enzymatic hydrolysis. But you see here, hydrophobic particles goes down in the beginning of the incubation experiment and then increases at 40 degrees. This is the same for 20 degrees, but here it remains stable. It shows that hydrophobic particles actually also act as antioxidants. It's consumed in the beginning and then it increases. This work has been submitted for publication in several journals and will be accepted in, it's already in press in lipid technology, and also in food chemistry it's been published now. What we also see is astaxanthin. Astaxanthin is a very powerful antioxidant. It can easily oxidize. It's actually the first things that oxidizes in krill oil. And it's a dramatic effect of temperature. At 20 degrees, this is blue line here. It remains stable but goes down gradually. 40 degrees, dramatic decrease in astaxanthin content. So if you see a krill oil with low level of astaxanthin, it's a sign of an oil that has seen very harsh treatment. High temperature, exposure to oxygen. This is another quality marker, we think, for krill oil. You should look for the astaxanthin level. If you increase temperature, you increase lipid oxidation, you increase non-enzymatic browning reaction, and the astaxanthin concentration is basically a result of what type of processing method applied and how harsh it is. Now, I want to summarize. This is the new krill oil quality markers which we propose. We think lipid intactness, because if it takes time before krill oil is processed, the lipids will break down. So you need to use, we propose NMR, 31P NMR spectroscopy. A high percentage value indicate that PC is minimally degraded due to immediate and gentle processing. High PE content, sign of both low lipid degradation as well as low oxidation, as the PE can react with the tertiary lipid oxidation products. Brownish color, very important. Low brownish color is a sign of low oxidation. As I said, astaxanthin content. High krill oil on astaxanthin content is a sign of low oxidation. Now we wanted to apply this to see, is there a difference on the different products in the market? And we went out in the shops in Copenhagen and purchased different samples from the different suppliers and different brands. And immediately we could see this one here is very brown and very difficult to get the oil out of the capsule. It was very thick and viscous. This is Rimfrost Sublime here, and it was clear red and free-flowing oil. This is Rimfrost Sublime, and this is the competing brand. We think there is something here about the color, and we continued to apply the other quality markers. This is the hydrophobic particles, which we measured. This is done at the Technical University in Denmark, and it's also going to be published soon. Rimfrost Sublime has the lowest level of hydrophobic particles, lowest level of brown color. The astaxanthin level is the highest in Rimfrost Sublime, while the competing brands has very low level of astaxanthin. Again, a sign that there's more harsh treatment on the competing brands. Now we also looked at the PE level, phosphatidylethanolamine. The phospholipid, that reacts with these oxidation products. And again, Rimfrost Sublime has the highest PE level. Competing brand has the lowest level. Looking at lipid intactness, meaning how quickly the krill is being processed. Rimfrost Sublime has a high lipid intactness, meaning low LPC, the degradation product from phospholipids, and high PC content, while this one is very degraded, and this one here is almost the same as Rimfrost Sublime. So this is also important to keep in mind, that there are differences in the lipid intactness, and this can be measured by NMR spectroscopy. Now we went in and looked at our data. We had 104 batches the latest 104 batches we had, we made a summary. And we see that the lipid intactness in our product is, on average, 92% for 104 batches. So it's very good reproducibility or good quality. PE content, on average, 2.6%. Brownish color, 0.019. And then astaxanthin content, on average, was 382 milligram per kilo. So a very high astaxanthin level. And that I have reached my conclusion. We have now discovered and done a lot of research to increase the knowledge of degradation mechanisms. We have published 3 papers on this, and there are 3 more coming. We have developed new quality markers. We think we have an increased understanding of the effect of processing temperature. And JUVEL has for the first time proven that efficient production of food products with high quality from krill is possible. Krill oil is available in dry form now. And this minimal and gentle processing, which JUVEL can do, preserve Krill Original's nutritional values. And that, I would like to thank you all for your attention.